All right, this is a video about question number 14 on your take-home formative. Now, question number 14 was slightly different from my version of the take-home to Miss Sampley's version of the take-home, but it got at the same idea, and a lot of students missed it, so I just wanted to give you this explanation of how to do it. Okay, so question 14, if we read it again, says, an ideal gas is collected over water. It's found to occupy a 50 cubic centimeter syringe at a pressure of 3.41 atmospheres and a temperature of 75 degrees Celsius. What's the pressure of the dry gas in kilopascals? A lot of students missed this question because they didn't recognize it as a gas over water question. And they thought, oh, I have to use the ideal gas law or the combined gas law. But no, this is an even easier question than that. All you have to use is subtraction. And how do you know that? How do you recognize this type of question? Because whenever it's talking about gas collected over water or asking you to find the pressure of the dry gas, that is a clue. Oh, hey, all I have to do is find my water vapor pressure at the right temperature and subtract that out to give me the pressure of my dry gas. So this is just a Dalton's law question. Okay, so we've got this gas that's collected over water, and when that happens, the pressure, the total pressure in the container is equal to the pressure of the gas that you collected. So I'll say gas collected plus the pressure of the water vapor because it was collected over water and that water vapor had a chance to be in the container as well. Okay, so this question tells us that the pressure inside the container is 3.41 atmospheres. And so that's going to be equal to the pressure of the gas that we collected plus the partial pressure of water. Well, how do we know what that pressure of water is? That's where this table comes into play. Now, there are a whole bunch of different pressures here, right? But we know that the temperature was 75 degrees. And so the partial pressure of water, here I have it in all these different units. Now, I know that that my units of the total container are in atmospheres. So I want to look at the pressure of water in atmospheres so I don't have to change that value. So 0.38 atmospheres. Okay, now to find the pressure of my gas, which is the pressure of my dry gas because it has the water removed, I subtract 0.38 from both sides, and so that I get the pressure of my gas equals 3.03 atm. Now, it told us that we have to convert it into kPa, so I would just take my 3.03 atm and do a quick conversion. I want to get rid of atm, so I put that on the bottom. I want to go to kPa, so that goes on the top. And then how do I make those values equivalent? Well, I have all my equivalent values right here. 1 atm equals 101.325 kPa. Uh-oh, I don't have enough room. 101.325 kPa. And when I multiply that out, then I get 306 kPa. And that's rounded to 3 significant figures because my pressure was given to me in 3 significant figures here.